That's a, aw, stink. That's a different, oh, man. Phooey. Different homology than the one we did. This has got z coefficients. Dang, nabbit. Well, anyway. Tell you what, next time you take topology, maybe you'll understand this.
Well, that was just a few simple examples.
Dang it. My homology is built over R. This is homology built over Z. If it's any comfort to you, there's something called the universal coefficients theorem that allows you to convert from one ring to another by a particular formula. All right. But the larger point here is that's 0, that's Z. You can't have an isomorphism from, you can't have an identity map from that to that. Right? It would essentially be a, you'd have the, when you look at this, you'd have basically the mapping Z to 0 to Z. And you can't have that. That's impossible, that diagram. So what that shows you is that there is no section. There does not exist a right inverse from S3 to S2. There's no way to continuously assign a particular element of S3 at each point, from each point in S2 in such a way that that assignment is continuous. You simply can't do it. So that's a much stronger thing than a simple number attaching to a space, right? It's a statement about the interrelation between spaces and the maps that are possible. That's what the existence of a functor brings into, and the proper understanding of a functor allows us to say things like this. And that's why algebraic topology is powerful. It's not just about attaching numbers to spaces, it's about the interrelation of spaces and maps. And then on page 75, he gives a careful definition of the higher homotopy groups. They're just homotopy classes of spheres into the space. So like homotopy curve, the first fundamental homotopy was like, we could look at it as circles into the space. Higher homotopy groups, you can look at it as continuous maps of higher spheres into the space. That's what the higher homotopy groups are. Weirdly, they're all abelian. It's just the fundamental group that could be non-abelian. Isn't that weird? Anyway, I hope you enjoyed your course in topology. Next time, analysis. So, my apology for all the definitions I've butchered.